In this video, we will discuss how to do Cartesian graphing in SageMath, also known as Sage, a free open source math environment that is based on Python but tailored specifically to mathematics. We will discuss graphing a mathematical function, customizing what your graph will look like, such as changing your colors, titles, labels, or other options, and finally saving your work in the format of your choice, such as a PDF. This video is designed for those without a prior knowledge of Python, but if you do have some background in Python, I think you'll still find this video useful because our process of graphing here is different and much easier than if you were to do this just in Python with a library like matplotlib or SymPy. The only thing you'll need to install to follow along is SageMath, which can be downloaded for free at sagemath.org. The link will be in the description. There's a few different ways to work with SageMath, but today I'm going to be using what's called the console, as you see here. That is what we have open on the screen. This is sort of like a scratch pad, and every time I type in a line and hit enter, because I'm using a PC, it will either run the code from that line, give me a new line to continue writing, or throw me an error depending on what I write, and it will know which one to do automatically. Note that anytime you see me write something like I have on the screen that starts with this kind of pound sign, the computer's just going to kind of skip that. It's just for human consumption. So that's called a comment, and sometimes I might put that in just to write out what I'm going to be doing. And with that, let's jump right in, and I'm going to clear out my heading here, and so to do that in SageMath, you just do exclamation mark clear, and it'll clear your screen. Okay, so critical to understanding how to graph something in SageMath is understanding the difference between a mathematical function and a programming function. These are both called function, but they have very different meanings. A mathematical function is something like f of x equals x plus 1, and let's just go ahead and make that a little bit bigger. So a mathematical function is something like f of x equals x plus 1. You've seen this in math class. You can think of this like a math machine almost. If you input any x value, like 2 or something, well, then you're going to add that by 1 and get your output, which is the f of x, or in terms of a graph, what you're going to plot on your y-axis. And so that's probably familiar to a lot of you, regardless of whether or not you have any experience in programming. But in programming, there is another different kind of function, which in Sage, just like in Python, is represented with the name of the function followed by a parentheses. And so a programming function you can think of in Sage as something like print. Let's do hello world, and that's kind of a very stereotypical basic function. And you see how I have print with hello world inside these parentheses. And so, if we were to actually write that in Sage, this time without our pound sign that indicates a comment, so this time the computer is going to read what we're doing. If we just did that, it would be, it would actually do something. It's an instruction to have your computer do something. And so it's a bit of a tongue twister, but Sage has a programming function that allows you to plot a mathematical function. And so to show you what that is, appropriately enough, it's actually called plot, and it's a function, so it'll have the word followed by parentheses. And so, as you can see, plot, plot, followed directly by parentheses. There's no space in between. And if you're familiar with Python, you might be used to having to install something special like matplotlib or SymPy and import what you need to use and have a lot of setup in order to start plotting a graph. Not so with Sage. Sage comes with this plot function right out of the box, just like Python comes with the print function right out of the box that we just saw. So you can just write in plot. And within this parentheses is where the magic happens, okay? And so within this parentheses is where we are going to put all of the instructions that we want for our graph, what the graph is going to graph and what the graph is going to look like. So one thing that we can do is just type in our mathematical function off the bat with nothing else, and we'll see how that looks. Our prior example was x plus 1, and once again, if you're familiar with Python and SymPy and you need to set a bunch of symbols to be x, you don't have to do this. I haven't imported anything, okay? This is just plot x plus 1, and let's hit enter and see what happens. And there it is. Look at that. It's given us a graph, and so, it might not be the prettiest graph, but it is a graph, and so something did happen, which is great, and it's a PNG file. It opened with my Photos program that is just the default Windows program, and it looks pretty good, all things considered. You can see we have our x-axis down here. We have a y-axis. Okay, that's great, and we have a graph of our line x plus 1, which is accurate. The 1 plus 1 is 2, and so the y value is properly 2 when the x value is 1. So and so on through this graph. So it looks good, okay, but it could look better. And so how do we make this graph look a little bit better? Well, what we can do is we can add more instructions inside these parentheses. And so once again, the screen is getting crowded just because I have it zoomed in so much for the benefit of those of you watching on a phone, but I'm going to clear it again. And so we have plot of x plus 1, like we did before. We'll just keep it simple because the syntax is what's important, not really what it happens to be that we're graphing in our example. And let's not close the parentheses yet. Let's put some more instructions separated by a comma. And so for those of you who know Python, this is akin to what we would call keyword arguments in Python. In Sage, they're actually called options. So since this is actually a Sage tutorial and not a Python tutorial, I'm going to call them options for the rest of this video. Though if you're coming from a Python background, it's you can think of it like keyword arguments and you'll get to the same place. So we are going to put in some options after our function, and we're going to separate them by a comma. If you go to the SageMath documentation, the link to which is in the description, you can actually see a list of all the options that you might have to customize your graph. I'm just going to show you the syntax and a few of the more important ones. But there's a lot more than I'm going to show you, so do take a look at that link in the description. So after the comma, you put in the name of the option, and let's do xmin, which is going to set a minimum x value on our x-axis, okay? And so that's the name of the option that we want to use, and you don't have to memorize that. It's on the SageMath website in the documentation that this is the name of the option for setting a minimum x value. Okay, so you type xmin and then an equals sign, and then the value that you want the minimum x value to be. And you can have a space before and after the equal sign if you want. It's going to work just fine, but not necessary. Okay, and let's do the xmin of -10. So to recap, we have a function, and by which I mean a programmatic function, called plot with these parentheses. Inside the parentheses, we're instructing the computer first and foremost, and it has to be first, to do this x plus 1. All the other things that come after that you're going to see separated by commas, the order doesn't matter, but this one has to be first, comma, and then, just some option that we want to use. Xmin is -10 in this instance, and let's see what happens. Okay, great. So now we have a graph. This is plot of x plus 1, and you see we do have a minimum value on our x-axis of -10. So this is exactly what we asked our computer to do, no less and no more. The computer isn't going to make a bunch of assumptions. It's not going to also give you a +10 here. We didn't ask for it. It's only going to give you, kind of the instructions that you give it. In this case, it's going to give you this -10 here. What if we wanted maximum value? Well, comma, xmin equals -10, and then, as you might have guessed, it's actually xmax equals 10, okay? And don't worry about going onto a new line. This ... indicates we're all still in the same line of code, technically speaking. It's just not going to make me scroll to the left and right, which is actually really nice. So now we have an xmin and an xmax, and I already see an error here, which is that I had put in a minus sign instead of an equal sign, so that would have been an error. So let's run it now. Okay, great. So now it looks much better. We have our -10, we have our +10. This looks really great, and you can adjust the y values with ymin and ymax. There's a number of other things you can do here. So let's take you through a few more examples of some other ways to customize any given graph. And so let's go ahead and clear the screen again. I'm going to do this a lot because I'm so zoomed in. Okay, so yeah, let's do a couple others. Why don't we try like color, for example? So let's do plot of, and let's just keep it simple and keep the same graph going. You know, you can graph anything with this, but let's keep it simple. And so let's do xmin of -10, xmax of 10, and now let's do color equals, and then within quotation marks, it can be a single quote, it can be a double quote, as long as it's consistent, but within quotation marks, put the name of the color that you want to use, or a hex value, for example, will also work. I believe you can do an RGB value as well. It's all in the documentation, but let's just do red, plain English, red like that, and let's see what happens. And now our line is red. Okay, so that looks great. And so, you know, a lot of colors will work in plain English like I did with red. You could also put a hex value in here like I mentioned, and you can just find those with a quick Google. And so if you wanted lime green, for example, just Google lime green hex value, and you know, then if you do, and I'm just going to copy paste it, though I will caveat that the copy pasting is not very intuitive. It's like control insert and then the pasting is shift insert. So I just want to give you that heads up. So let's paste it, and you see also it kind of gives me, and this wouldn't be a problem if I was using the Jupyter notebook that comes with, that also comes with SageMath, but because I'm just using the console, it's very clunky in how it does things like copy paste. But we got there in the end, hopefully. So this time I'm going to paste in that I have on my other monitor here a hex value for lime green. Okay, and now let's hit enter. Okay, great. And so now you see we have this lime green, you know, thing. So if we were the Minister of Magic, that would be what we have our color of our bowler hat. All right, so you can change the other things. You can change the so-called style of your line with something called line style is another option, just like in matplotlib. So just to show you, I'm not going to type in every single option again, but just to show you, line style equals, and then you could either do 2 dashes like that, or you can actually type the word dashed, which might be easier to remember. And this is going to give you a dashed line now, so that's great. You can change things like your title, so you can add a title. So if you do plot of x plus 1, line style equals dashed. Let's just go bananas and have the xmin is -10, the xmax is 10, and then now let's have a title too. And the title, why don't we just make it f of x equals x plus 1. Very true to life, because that is, of course, what we're graphing. And there it is. Look at that. We have our nice title, f of x equals x plus 1. We have our line style is dashed. We didn't change the color this time, so you know it is just going to default with different colors for different lines, and that's fine. But this is all good, and it looks pretty good, and it's exactly what we wanted. We have our xmin, our xmax. It has all the options that we wanted to give it. So let's do something a little different here. Let's plot 2 different lines on the same graph, and we can do that with variables, and we can do that by setting a variable, storing our plot inside what's called a variable. And a variable is any, it's basically like a word. You can separate it with underscores if you want. And so let's call it line1. And so that's going to be my variable where I store my plot. Okay, and so this time, instead of just writing plot, we're going to write line1 and then equals. And if you're familiar with Python, this will be very familiar to you because, of course, this is just the same way that you do it in Python. But for those of you who might not have that background, all I'm really doing, this equal sign isn't like a mathematical equal sign. It's just kind of a programming syntax and a way to tell SageMath, I'm going to make a variable, I'm going to make something called line1, and I'm going to store it, something else inside that variable so that every time later on in my console, or if you're using, a Jupyter notebook for a bigger program inside my Jupyter notebook or whatever, then, every time I say line1, I really mean whatever I store inside here. And so plot of, x plus 1, and let's, let's go ahead and make it a color equals red. Don't forget the quotes like I almost did. Line style equals dashed, xmin equals -10, xmax equals 10, and let's give it a legend. And that's what the option legend label, which is legend underscore label. Don't worry that it's breaking, it looks like it's breaking across lines. It's really not, I'm just really zoomed in. So legend underscore label equals, and let's just call it x plus 1. And then let's do the same thing. Well, first let's hit enter, and you'll notice before when we hit enter, a whole graph popped up. It's not going to happen this time. It's just going to give you the next line to enter more code, but it'll remember that this is line 1. Okay, so now let's make a second one called line 2. And let's make this one a little different. Let's go ahead and do plot of, why don't we make it x, why don't we make it 2 times x? And so this is important. If you were just writing this by hand, you'd just write 2x, but you actually need this star to indicate multiplication. For SageMath, it's not going to understand 2x. You have to have that star. Okay, so let's just do it 2 times x and just keep it simple. Okay, and so why don't we make our color teal, just to show you that there are actually quite a few plain language colors that come with it. And the legend label, let's make it 2x. Let's make it function of x equals 2x. And let's just make it 2x because then it's gonna be similar to the one we already did. And so that's fine. And let's not put in the xmin or xmax, and you'll see something interesting that happens when we have the xmin and xmax in our first one and not in our second one, okay? And so, of course, what did we just do here? All we did is we stored this plot inside the variable line2. So now we have 2 different plots, each of which is stored inside of a variable. And so to show those, all we need to do is type line1 plus line2, and that's really it, because this is going to just basically do the line1 plus also, do the line2 is all it's saying, and it's going to do it all at once and combined. So let's see how it looks. And there it is. We have our legend, we have our dashed line for x plus 1, we have our kind of blue solid line, our teal solid line for 2x, and so that looks great. Notice that, I didn't bother rewriting my xmin and xmax on our second line, and our second line reflects that. It plotted out just with the default min and max that we saw before of 1, and so Also notice, that the legend is up here in the upper left-hand corner. Again, just a default, you can move it. The documentation has different options for how to move, if you have a title, how to position the title, how to position the legend, all that. But again, it's more important right now that you have the syntax down, and then you can go to the documentation and you can see all the different ways that you can customize these further, that is. Okay, and then finally, let's save our graph, and we can save our graph as a PDF or some other format. It actually can do a number of formats, but let's make a variable and let's call this one my graph. And let's put an equal sign to show that we're about to store something inside this variable. And then let's do a new plot. Let's do plot, and here's an interesting point where SageMath differs from Python. Let's do x squared, which can actually be x caret 2. It can certainly be x star star 2 for x squared, which, those of you watching who know Python are going to be more comfortable with, but, SageMath is actually, unlike Python, happy to do x caret 2 as well, which might be a little more user-friendly or easy to remember for those of you who don't have that Python background. Okay, so plot of x squared, minus 4 or something, okay? And so, comma, all right. And I don't know, let's do a couple of options just to make it look good. Maybe xmin of -10, xmax of 10, I don't know, color of, let's do red, and what else? I mean, I think that should be fine to get the point across. And so let's store it. And so now we have this plot, which is going to be x squared minus 4 inside my graph. All right. And let's close the parentheses, hit enter. And so now we need somewhere on our computer to save our graph to. And I already have a folder set up in Windows Explorer. So let's go there. I have this folder set up just with kind of a generic name. And so we can copy our path here. And then, now remember we have that in our clipboard. And then what we can do is we can do another different function. Remember how plot was a function? We can do another different function called save. And the way that save is going to work is first you type the name of your variable, which in our case is my graph. Then you type dot, just a period, okay? You type the name of your variable, dot, and then save, okay? Name of your variable dot save, and then inside your parentheses, you put in quotation marks, and that is key, in quotation marks. It can be a single quote, it can be a double quote, it just has to be consistent. And you put where you want to save it, okay? And then another backslash, and here's where you give your graph a name. I'll call it, I'll just call it my graph. Okay, and so this is, actually, that might be confusing. It's not going to always be the name of your variable. I'll call it sample graph. Okay, so your name, and you end it with the extension that you want to save it as. In this case, just to show you an example, I'll save it as a PDF. And you do .pdf. Don't forget to end your quotation marks. This whole statement here has to be in quotation marks. Don't forget to close your parentheses. Okay, so you are giving your computer an instruction inside these parentheses, mygraph.save, parentheses, quote, your file path, another backslash, and whatever you want to name your graph, dot, and then the file type as your extension. All right, and hit enter. And you see like a bunch of stuff happened, but it doesn't matter. Where is our graph stored? Well, let's go back to our folder and see if it worked. There it is. There it is. Remember before this was empty? Now we have something called sample graph. Let's open it. Oh, look at that. And it's a beauty. We've got our red line, we've got a curve. You know, again, if you are used to like matplotlib with just Python and you need to use NumPy and linspace to make curves like this, no, with SageMath it's much easier. You have your curve and it looks great. It looks, it has all of the different options that we wanted to give it. You could have given it a title, of course, a legend, put in a couple of different things, and it's saved as a PDF. I just opened it with Acrobat Reader, that's that's it for today's video. But do take a look at the documentation because you can play around with the different functions you can graph. You can certainly play around a lot more with the options. And so take a look at that, but that is it for today's video on graphing in the Cartesian plane with SageMath, which covered kind of the plot function that comes with SageMath, some of the options you can put inside that plot function, and then how to save your graph in different formats using, just as an example, a PDF. Thank you very much for watching.